Hello. In our last video, you noticed that how we can write our exponential function equation. It's going to be y equals a times b to the power of x. And then also we saw how we can graph our function, and our graph is going to look something like this, okay, where it never crosses the x-axis, but it's going to go up forever, never, never, never. Now, notice that it's starting here really low, and then it's coming up to the right really high like this. This type of graph is a specific type of graph, and that's what we're going to be talking about today, and that is the exponential growth model. All right, so our exponential growth model, I'm going to write my equation here, is y equals a, once again, there's that a again, times, I'm going to put in parentheses here, 1 plus r to the t. Okay, y equals a times 1 plus r to the t. Notice that the 1 plus r is being raised to the t. We have all these things around here, and I'm going to use those to identify what the different pieces are. So first off, the a. The a is the initial amount. Initial amount. So whatever we're starting off with, that's what this a is going to be. Okay? The next one is the r. It's supposed to be pointing to the r. So the r is the growth rate. Okay? And notice that we have here a little t. T is the time period. And last but not least, notice how this is pointing over here, but this is actually pointing to this entire thing right here. So this is pointing to that entire thing that's in parentheses. So that 1 plus r is actually the growth factor. Okay? In the previous example over here, this b is going to be our growth factor, but notice in this, in the exponential growth model, our growth factor is this whole expression 1 plus r. Okay, so now that we know what the pieces are for our exponential growth model, we can actually use this for a bunch of different types of problems related to the real world. And so, I mean, some of the examples can be, how fast a virus spreads across the world, or another one could be, in this one, how much the value of the car is increasing over an amount of time. All right, so there's a bunch of different ways we can express the exponential growth. So anyway, in this example, it says the owner of a 1953 Hudson Hornet convertible sold at an auction. Okay. It says the owner bought it in 1984 when its value was $11,000. Okay, the value of the car increased by a rate of 6.9% per year. All right, so we have all of this information. We're going to have to apply it to this exponential growth model. So let's figure out the pieces that we have. First off, we know that in 1984, it cost $11,000. So we know that our value in 1984 is going to be $11,000, because that's what it's starting at that year. Okay? It says it increased at a rate of 6.9%. So we know our rate is going to be 6.9%. But when we work with these, we have to put this in terms of a decimal. So everybody should know how to convert a percent to a decimal. This is going to be 0.069. Okay? And then here we can see that it's going up per year. So I know my time period is going to be in years. Is going to be the number of years. And that will be since 1984. And then I also know that y is actually going to be the value of the car at any year. At any year. So with this information, I can write my function. So y is the value of the car, so it's going to be y equals, my initial value of the car is $11,000, so it's going to be 11,000 here, times 1 plus my rate is, my growth rate is 0.069, and my t and my time is here as t. So now I have my value for the car, which is y, and my time, which I don't know what the time is yet. So that's my function. I just wrote a function that models this value, okay? Next part says, the auction took place in 2004. What is the approximate value of the car at the time of the auction? So what we need to do is figure out what t is in 2004. So what I can do is just simply take 2004 and subtract it from 1984, which was when that initial value was, and then I'm going to get 20. So now I know that t is 20. I can substitute that in here, and then I can figure out what my value of the car is at year 20 or in 2004. So doing that, I have y equals 11,000 times 1 plus 0.069 to the 20th power. Whenever you're doing these problems, I would highly recommend not rounding it until you get to the very end. So what you should do is do this addition in here first. So it's still $11,000 here. This is going to be 1.069 to the 20th power. And then what you can do is take 1.069 to the 20th power and multiply it by 11,000, and you're going to end up with, I came up with approximately 41,777.92. So it wants to round to the nearest dollar. So this is actually going to end up being the value of the car. Would be $41,778. And that's it. That's how you will use the exponential growth model. Bye.